Okay, so now let's jump to section 10, which is advanced pad generation part 1. Um, Here we'll learn how to use way more advanced feature than what we've used so far in terms of generating robot path or trajectories. The goal here is to really give you a way to create those more complex path where you really need to follow a specific surface. Let's say for gluing, dispensing, polishing, welding, or if you need to do some material removal, some cutting, some milling, if you need to do some 3D printing, if you need to do a lot of those kind of more advanced, let's say, application with robots. By the way, those are getting more and more common. We now reached, I was reading the other day on the IRA website that for the first time in 2020 we reached a point where we have more applications that aren't pick and place than we have applications that are simple pick and place. So that means that all of those more advanced application for inspection, welding, polishing, dispensing, milling, cutting, and so on and so forth, 3D printing are getting more and more traction on the market. But the point is that those are generally very hard to program just manually by hand because they require you to first be super accurate with respect to a part, but create a lot of points. So if you start trying to hand teach, like moving the robot, teaching a point, moving the robot, teaching a point, that will work for a few dozen, even potentially a few hundred points if you're very patient. But as soon as you're getting like in the hundreds and thousands of points, that's just not worth it. And also it's very useful for a situation where you have low volume, high mix type of production where you need to reprogram the robot often because you can basically generate the program offline, first of all, without taking any production time off the robot, and also with I'm going to show you way more advanced tool. So first of all, let's do just a first quick overview of what kind of application we can cover. So I'm going to open here 10A FANUC dispensing. So here we have a FANUC robot with a small dispensing head for sealant or glue, something like that. And we have a groove around an oil pan here. We need to dispense some glue. So what we could do here would be to have the robot follow that groove, follow that blue line here, so that it can actively apply the sealant. And that kind of pad here would take a good few minutes, if not at least I don't know, a few hours potentially to program properly. A few dozen of minutes if you're very quick. We can do that with RoboDK in like less than 5 minutes if we know what we're doing, and that's my goal here today, show you how you can do that. Another example here, so this was a dispensing example. Here we have a this is a bit too much. We have a polishing example with 2 UR robot on top of a car hood. So if I start that program here, we have both robot following that path here. And so those lines were created using a CAD software, so SolidWorks or Solid Edge in this case. I can't remember which one I used for this specific example, but we're gonna cover that in a future video. So it's gonna be like in the next section 11. But the point is that it's super easy with the tools we have to create such path. In fact, what we do is we create a 2D sketch of the path we want. So we created it like that, 2D sketch, like a few centimeters on top of the part, and then we use the CAD software. When I'm talking about CAD software, by the way, it's computer aided design, so any 3D modeling software that we support. And then Starting from there, we project that on the surface, and that will give us a 3D sketch, and then we import that 3D sketch to RoboDK in order to have that that path here that we can use. So every time you see a little white arrow, this is a point, and as you can see, they are always normal to the surface, so that we have a good, let's say, contact between the sender and the actual surface we're trying to send. So real quick, if we go to, if you want to reach those features, you go to utilities, and then here you have robot machining project, curve follow project, point follow project, 3D printing project. I'm covering those all in one bundle for the simple reason that they are all pretty much the same in terms of functionality and how you would work with them. So if I open the robot machining project, it looks like that. If I go and open the curve follow project, it looks like that. So as you can see, things are very similar from from the user standpoint or from a user perspective. There's the only real difference is what kind of input you're using. So for a machining project, we'll be using an NC file, so a numerical command file that would be destined to a CNC. If we are using a point follow project, we're going to use a curve follow project. We're going to use a curve, which is a bunch of points linked together. If we were to use a 3D printing project, would be using a G code coming from a slicer. So all of those features, all of those are pretty similar, as you can see here, and that's why I'm going to start with the curve follow project. So we're going to kind of learn how to use that tool just on small sections of paths, of some small path sections, and then we'll be able to reuse that knowledge to bigger programs. So it's easier to learn on smaller sections, understand the quirk and the features, and then take that knowledge, apply it to a bigger program afterwards, either a cutting program or sanding program or 3D printing program, which can have like hundreds and hundreds and hundreds of points. So to give you an idea, like just those here, this path here has 1,300 points. The other one here has 1,250. So that starts to be quite a big amount of points. And I couldn't just do a straight line here because, as you can see, there's a small deviation all the time here. So if I really want to be normal to the surface at all time and having the best path possible, this is the best method and the fastest method around. So let's so I'm gonna finish this introduction video and let's start with the curve follow project.